Have you ever wondered if a cat could be both alive and dead at the same time? Sounds absurd, doesn't it? Yet this is a question that arises when we delve into the fascinating world of quantum physics. Unlike the rules of classical physics that govern our everyday life, quantum physics deals with the bizarre and often counterintuitive phenomena that occur at the microscopic level of atoms and subatomic particles. Imagine a universe where things exist in multiple states at once, a world where particles can be entangled across vast distances, where they instantaneously affect each other. This is the realm of quantum physics. The Schrödinger's cat thought experiment, where a cat can be considered both alive and dead until observed, is a classic example that highlights the peculiarity of this field. So, why is quantum physics important? Well, it's the foundation of many modern technologies and gives a deeper understanding of the universe. Welcome to the strange yet fascinating world of quantum physics. Intrigued by this compelling and peculiar world? Subscribe now and stay tuned for more enlightening content on quantum physics. Imagine you're flipping a coin. It's either heads or tails, right? But what if it could be both at the same time? Welcome to the world of quantum superposition, where the usual rules of reality take a back seat. In the quantum realm, the coin isn't just heads or tails. Instead, until you catch it in your hand and take a peek, it exists in a state where it's both heads and tails simultaneously. This might sound like stuff of science fiction, but it's a core principle in quantum physics. It's called superposition. You see, in the quantum world, particles can exist in multiple states at once, and just like our coin, they don't settle into one state or another until they're observed or measured. Think of it like this. Imagine you're at a fork in a road. In the classical world, you would choose one path or the other. But in the quantum world, you could effectively travel both paths at the same time. And it's only when someone observes you that you choose one path. But how can something be in two places at once? Well, that's where the magic of quantum mechanics comes in. Every particle is described by a wave function, a mathematical expression that encapsulates all the possible states that particle can be in. And until we observe the particle, it's essentially smeared out over all those possibilities, existing in a superposition of states. Once we observe or measure the particle, this wave function collapses and the particle settles into one of those possible states. So, it's our observation that forces the particle to make a choice. That's superposition, a fundamental principle of quantum mechanics where things can be in multiple places at the same time. Mind-blowing, isn't it? What if I told you two particles, no matter how far apart, could affect each other instantaneously? Welcome to the world of quantum entanglement, a mind-bending concept that turns our understanding of the physical world on its head. Imagine tossing a pair of dice. Normally, the result on one die has no effect on the other, but in the quantum world, it's as if the two dice, no matter how far apart, always roll the same number. This is the essence of quantum entanglement. In the early 20th century, Albert Einstein, Boris Podolsky, and Nathan Rosen proposed a thought experiment that shook the foundations of quantum mechanics. They questioned the very possibility of two particles influencing each other instantaneously across vast distances, a concept they found spooky. Einstein famously referred to it as spooky action at a distance. Fast forward to the modern era, experiments have confirmed that this spooky action is real. When two particles are entangled, the state of one particle is immediately reflected in the other, even if they are light years apart. If the spin of one particle is measured and found to be up, the spin of its entangled partner, no matter how far away, will instantaneously be down. This instantaneous interaction defies our everyday understanding of how the world works. It suggests that information can travel faster than light, a speed limit thought to be inviolable according to Einstein's theory of relativity. Yet, quantum entanglement doesn't transmit tangible information, and so, it doesn't violate any physical laws. It simply binds the fate of entangled particles in a mysterious, unbreakable bond. Quantum entanglement is not just theoretical speculation, it's the driving force behind emerging technologies like quantum computing and quantum cryptography. It's a cornerstone of our understanding of the quantum world, a world that's strange, counterintuitive, and absolutely fascinating. This mind-boggling phenomenon is quantum entanglement. It challenges our understanding of the very nature of reality. So buckle up and prepare for a wild ride as we unravel more mysteries of the quantum universe. You might be wondering, does quantum physics have any real-world applications? Well, let's clear that up. Quantum physics, although it seems like a realm of abstract and complex theories, actually underpins much of the technology we use every day. Let's start with lasers. The acronym LASER stands for Light Amplification by Stimulated Emission of Radiation. This technology, used everywhere from barcode scanners to eye surgery, fundamentally relies on quantum mechanics. In a laser, atoms are excited to a higher energy level, and when they fall back to their ground state, they emit a photon. This process, described by quantum physics, allows the generation of a coherent and concentrated beam of light. Next, let's talk about magnetic resonance imaging, or MRI. This powerful medical tool, which allows doctors to view the inner workings of the human body in real time, also operates on principles of quantum physics. The machine manipulates the spin states of atoms in your body to generate images, a process made possible by understanding quantum mechanics. And remember, the computer or smartphone you're using right now, it wouldn't exist without quantum physics. The transistors in these devices, which are the building blocks of digital electronics, operate on quantum principles. They use the properties of electrons, including their charge and spin, to process and store information. Quantum mechanics also plays a crucial role in the development of new materials with novel properties. For instance, superconductors, materials that can conduct electricity without resistance, were discovered and understood through quantum physics. These superconductors are used in many applications, including MRI machines and particle accelerators. In addition, quantum technologies promise to revolutionize fields like cryptography and computing. Quantum encryption can provide theoretically unbreakable codes, while quantum computers could solve problems far beyond the reach of today's most powerful supercomputers. So, yes, quantum physics is not just theoretical, it's part of our everyday lives. Whether it's lasers, MRI scanners, computers, or even the promise of future technologies, we are surrounded by the practical applications of this fascinating field. Now that we've delved into the quantum world, where can it take us in the future? Well, the possibilities are as countless as the particles in a quantum system. Quantum physics, with its peculiar but powerful principles, promises to revolutionize numerous fields, from medicine to computing and from communication to transportation. Imagine a world where computers are exponentially more powerful than they are today. That's the promise of quantum computing. By leveraging the principles of superposition and entanglement, quantum computers could perform many calculations simultaneously. This could enable us to solve complex problems that are currently beyond our reach, bringing about a new age of technological advancement. Now let's take a quantum leap to the field of medicine. Quantum physics could potentially reshape the way we diagnose and treat diseases. Quantum sensors could detect diseases at their earliest stages, possibly even before symptoms appear. Moreover, quantum algorithms could help us understand complex biological systems, paving the way for new treatments and perhaps even cures. But the quantum future doesn't stop there. Picture a world where information can be transmitted instantaneously, regardless of distance. That's the potential of quantum teleportation. Using the principle of entanglement, information could be sent from one location to another without any time delay. This could revolutionize communication, making our world even more interconnected than it already is. And while these quantum possibilities may seem like science fiction, they are becoming more real every day. Researchers around the globe are making strides in understanding and harnessing the power of the quantum world. So, as we stand on the brink of the quantum future, it's clear that our journey into this fascinating realm is just beginning. The quantum world, as strange as it seems, holds the key to our future. And with every quantum leap we make, we get one step closer to unlocking its full potential. The quantum world, as strange as it seems, holds the key to our future. So, we've journeyed into the quantum world, and it's been a wild ride. We've grappled with the mind-bending concept of superposition, where particles can exist in multiple states at once until observed. This isn't some abstract theory, but a principle that shapes the reality around us, even if we can't see it with our eyes. We've also delved into the enigma of entanglement, that curious phenomenon where particles, no matter how far apart, can instantly affect each other's states. It sounds like something out of a sci-fi movie, but it's an integral part of quantum mechanics. And we've not only ventured into the quantum realm purely for exploration's sake, but also looked at how quantum physics permeates everyday life and the promise it holds for the future. From quantum computers that could revolutionize technology to quantum teleportation that might redefine the impossible. Quantum physics, though complex, is a fascinating field that opens up a world of possibilities. So, keep exploring, keep questioning, and who knows where your quantum journey might